Hi guys, I hope you are fine. Guys, let's do this question. And we are going to do this question using the polar coordinates. I first of all read the question. Evaluate the integral from 0 to 1, and then again integral from 0 to square root of 1 minus x squared of xy dy dx all over square root of 1 minus x squared minus y squared. So guys, we start this question and we start with drawing the domain. This one guys, we had already drawn it. And so guys, what we are going to do, we are now going to integrate along the x-axis, the y, the r-axis. We are going to integrate along the r-axis where our r at this point, the circumference r is equals to 1, and at this point r is equals to 0. Again guys, we are going to integrate, that is to sum up the strips along the circumference from theta equals to 0 up to this point, which is theta equals to pi over 2. So guys, I can now draw the integral here. That is the first integral, the second integral. So the first integral guys, I'm going to move along the radius, so that guys I'll have 0 here, and then I'll have here is supposed to be 1, and this one is with respect to dr. Then with respect to theta, I'll move from 0 to pi over 2, from 0 to pi over 2. So guys, I should have that in mind as I write my d theta and dr, meaning that I'll start with dr. But before that guys, we have r, x is given by r cos theta, and y is given by r sin theta. So guys, we replace that. This equation will replace for that. So this one guys is going to be, our x is r cos theta, our y is still going to be r. I can put this r here so that this one becomes squared, sin theta, like that. Then over here guys, we are going to have 1 minus, this is going now to be r squared cos theta square plus sin squared theta. It's going to be like that guys. Then we also replace our dy and dx. For dy dx, this one comes to r d r and then d theta. This one guys, we arrange according to the integral we have put in place, so that guys, if we start with, we've started with integration with respect to r radius, and so I have put the r there. So guys, we continue now from there. Guys, we can integrate now, starting with the inner integral, whereby guys, we are going to have integral 0 to 1. We start with this one and then we shall end up with that. So this one guys is going to be, you can multiply that r and r there. You have r cubed cos theta sin theta, then we have the dr. We shall use the d theta next. So at this moment, we are doing it with reference to r. So cos theta and sin theta are actually constants at this moment. So the denominator is going to be 1 minus r squared, because this is going to be 1. So guys, from there we go ahead. Now we can now put the constant, which is cos theta, sin theta. We are saying they are constant because we are integrating with respect to dr. Then we are left with integration from 0 to 1 of r cubed all over square root of 1 minus r squared. So guys, from there we can say let r be equal to sine u. And so therefore guys, we are going to have dr all over du is equals to cos. So you have cos u. So I can put now my du right here. So I can transfer this du right there. And so therefore guys, we are going to have our equation then is going to be cos theta sine theta. We are going to have from 0 to 1, we have r, which is now sine u, and that one guys is supposed now to be cubed all over. Guys, we can replace for dr is cos u du. For this guys, we are going to have 1 minus square root of 1 minus r squared, which is sine squared u. This one guys is going to give us cos squared, square root is cos u, like that. So guys, we are now going to cancel that. We can cancel that and that. So guys, we are left with cos theta sine theta. We come now guys and integrate that. So in integrating that guys, we will say from 0 to 1, we can divide this one into 2. That is sine squared, or let's say sine theta, sine u, and then we say sine squared u, which is the same as 1 minus cos squared u, like that, du. So guys, now we can come and again we evaluate that sine theta. So here guys, we are going to have sine u minus sine u cos squared u, and always du, like that. So guys, from there we are going to have cos theta sine theta. We now integrate that. So guys, if we integrate that, we are going to have minus, for this one is cos u, and for this other one guys, we are going to have plus cos cubed u all over 3. So that is going to be our integration. Guys, I can give you homework. You come and replace, for example, you say u or w is equals to sine u. Use substitution, guys, and you find that it is going to come to this. So guys, now this is now going to be from 0 to 1, but then guys, this was for R, and so guys, we can transform our limits from R to U. So guys, we come here and say again, R is equals to sine U. This R is equals to sine U. So we put here R equals to sine U. Therefore, when R equals to 0, U is supposed to be equal to 0. When R equals to 1, then U is also equal to, this is supposed to be, this is pi over 2, pi all over 2. So guys, now we come and replace for that, whereby this one you are going to have 0. That is the first U, and this is pi over 2. So guys, let's do that and see what we get. So this is going to be equal to cos theta sine theta. When we replace for that, guys, we shall have minus, first of all, minus cos pi over 2. This one will come to 0, and this one will also come to 0. So we are going to write 0 there. And then, guys, we come and minus. We come and now put cos 0. For cos 0 is equals to 1. So we are going to have minus 1 there. Then plus cos 0 is going still to be 1. So this one is going to be 1 all over 3, like that. And so guys, we shall have cos theta sine theta, like that. This one is now going to give us, guys, if we do this one, is going to be now plus minus. So this is going to be 3 over 3 minus a third, because this is plus, this is minus a third. So guys, we are going to have 2 all over 3. This is going to be 2 all over 3, like that. Guys, now we integrate that now with respect to d theta. As we have seen here, guys, we do it now with respect to d theta. This is the d theta from 0 to pi over 2. So that's exactly what, guys, we are going to do here. From 0 to pi over 2, like that. So guys, we are going to have 2 all over 3 integral from 0 to pi over 2. Then we have cos theta sine theta d theta. This is going to be d theta. Here we should put d theta, like that. So guys, from there we are almost finishing. We can say let u be equal to sine theta, like that, so that du is equals to, that is du d theta equals to cos theta. And so therefore, guys, our d theta, then you'll have d theta equals to du all over cos theta. So therefore we bring this now here, we integrate now here, we say integral from of 2 over 3, that is 2 over 3 integral, we come and write our cos theta there. After writing cos, the limits are 0 to pi over 2. Then we write, here we write sine, but sine now it is supposed to be u. Then we have the d theta. For the d theta is supposed to be du over cos theta. So we write here du all over cos theta. So therefore, guys, that one is going to be cancelled. So we shall be left finally, guys, with this. Hereby we say 2 all over 3. We come and now integrate u. Integrating u, we shall have u squared all over 2. From now 0 to pi all over 2. But guys, we know that u is equals to sine theta. So we can change this. Can actually change this and write for theta equals to 0. This one will still give us 0. That is sine 0. For sine pi over 2, that is going to give us sine 90 gives us 1. So this one is going now to be 1. And so therefore, guys, we can replace for that. 2 all over 3. We can now put 0, it's going to be 0. Now we put 1. All over 3 now, all over 2. Like that. So guys, our solution then is going to be that. So guys, thank you for listening to me. Bye bye.